A very good morning to Madam Hetena Binti Jajo and to all my fellow friends. So today we will presenting our presentation 2 of Engineering Mathematics 1 DBM10013, and the topic is vector and scalar in engineering. So the lecturer in charge in this course is Madam Hetena Binti Jajo, and our group member is consists of me and myself, Muhammad Izam Fahmi. My matrix number is 07DKM23F2010.
My name is Muhammad Fadaiman and my matric number is 07DKM23F2012.
My name is Muhammad Syafiq bin Nasdin. My number matrix 07 DKM 23F202F.
My name is Muhammad Darwis bin Rashid and my matrix number is 07 DKM 23 F2034.
I'll begin our presentation by presenting the introduction. So, what is scalar and vector quantities? Scalar and vector quantities usually used to describe motion of an object. Scalar quantities are defined as physical quantities that have magnitude or size only. For example, distance, speed, mass, density, and elantra. How about vector quantities? Vector quantities is physical quantities that have magnitude and direction. I want to highlight is magnitude and direction, such as displacement, velocity, acceleration, force, and etc. It should be noted that when a changes similarly, when a scalar quantity changes, only magnitude changes.
I will present laws of vector addition. Laws of vector addition can be defined using any of the following laws. The first one is triangle law. If two vectors are denoted by the sides of a triangle in the same order, the resultant vector is given by the third side of the triangle taken in the opposite. The second one is parallelogram law. If two vectors are denoted by two adjacent sides of a parallelogram, the resultant vector is given by the diagonal that passes through the point of intersection of those sides. The resultant addition of two vectors A and B with magnitudes A and B is given by C equal A plus B. The resultant vector C has magnitude. It makes an angle with the vector such that C equal tan theta. I will pass to my next friend. Thank you.
Alright, application of vector. A vector quantity is a quantity marked both in magnitude and direction. Length and magnitude are represented by absolute symbol. By using vector and scalar, the satellite can find the direction and the distance between the satellite and the GPS receiver. Alright, now we come to the conclusion. The conclusion, vectors are very important in engineering. So, we know the vectors are used in engineering to represent quantities that have both a magnitude and direction. Many engineering quantities such as force, displacement, velocity, and acceleration will need to be represented as a vector for analysis.
I'll continue the presentation by showing you the mathematical solution for scalar and vector. Let's look at the question. The position vector of P is 4, 3, and the position vector of Q is -2 and 5. So now we have to find the vector of PQ. So the solution for this is vector PQ is equal to vector PO plus vector OQ. After that, we have to inverse the vector PO to vector negative OP, because as we all know, every vector must come from the origin, which is the O. After that, we subtract the value of every vector into the calculation. So for vector of negative OP, it's equal to negative 4, 3, and for vector or q, it's equal to negative 2 and 5. So after that we just have to addition it. So negative 4, 3 plus negative 2, 5, it's equal to negative 4 minus 2 and negative 3 plus 5. After we calculate the negative 4 minus 2 and negative 3 plus 5, we will get the value of PQ, which is negative 6 and 2. That's all from me. I'll pass to Shafiq.
I will continue presentation. Thank you to Izan. Okay, example 1. The question 1, find the area parallelogram. Okay, I can give you solution. BC times BA. We find IJK. The way to find I is firstly we use the way to find the minor is 3 times 1. After that you subcontract to get value of I. Okay. J, we can find we can check that the value of is equal to K. Then you just multiply the same as find the same value of I, then just subcontract in it to find the value of J. And then K, the way it's the same as I, only we look at the value of I and J just using the minor. After that, search the magnitude BC times BA. Square root 1 square 2 minus negative 1 square 2. After that, equal square root 1 plus 1. You can get square 2 u square.
The conclusion: vectors are very important in engineering. So we know the vectors are used in engineering to represent quantities that have both a magnitude and direction. Many engineering quantities such as force, displacement, velocity, and acceleration will need to be represented as a vector for analysis.
That's all from us. Thank you.